Hello students, in this video what I am going to learn you is the Mohr circle. I can teach you through my graphics 8 pan as well, but I need to draw it as well. So it will be quite difficult on that to learn you. So first of all, I will tell you how can you search it out Mohr circle from the book. So this is your strength of material book, and hopefully it is visible to all of you guys. And which is the Mohr circle? So let me see that. Where is the Mohr circle? So we have to search it out. This is double integration method. We have already learned that. And where is the Mohr circle? So let me search it out. Where is the Mohr circle? So this is Mohr circles for moment of inertia. No, not this one. This is the Mohr circle in the chapter of combined stresses, chapter number 9. So you have to move on 326 page number. So for the Mohr circle, what do we know that 326 page number? So these are some pages on which I have to describe you what is exactly the Mohr circle is and why we are calculating. So you all guys, all you know that what is the stress and strain. So what is the definition of stress and strain? So I must tell you over here that we have two types of stresses. One is the shear stress and other one is the normal stress, and what it actually is. So let me tell you is that, so this is your book, but right now I am going to draw it over here so it may be more visible to you, all of you. So let me draw it here. So what do you have to do? You have 3D diagram and this one. So whenever you have the cube and anything, so what I am going to tell you, so this is the cube, or you can say it can be cuboid. So it is the, for example, any material or concrete, whatever it is. So what happened with it? So let me tell you is that this is the way to make the cube, and what I am going to tell you is that at every face there will be the perpendicular force and there will be the parallel force. So what is the perpendicular force? So if it is perpendicular, so you have to represent it with what? Sigma. Or and what you have to do, this is the parallel force, so you have to represent with the tau, and you have to use the subscript as well for this sigma and tau. So what will be the subscript? So let me tell you here. For example, this is your x-axis, this one is your x-axis, this is your origin, and obviously there will be the z-axis as well. So there will be the z-axis as well, and this is your y-axis. So what will happen? This force is parallel to x-axis. So what you have to do? You have to write its subscript at sigma x, and this will start from x, and this is the perpendicular. This is the parallel to y-axis. So you have to write down tau xy. Same goes with other sides as well, other planes. So for example, on the base, what will happen? This is the condition. This one, this is sigma y. This is sigma y because this force is parallel to y-axis. So you have to write down sigma. This is the normal stress. And what is this? This is tau. So it should be tau yx because of this y. So tau yx. And you have to see over here is that this is on this plane. So what will happen? Let me shade the region. So for example, this is the face I'm talking about. This one is the face, or you can say I have the color pencil as well, so I can color it as well. So I am coloring so badly, but it doesn't mean that I cannot draw and I don't have good drawing. So you can see over here, this is this face. At this face I am drawing the, and I am drawing on this face. So these are the faces on which I am drawing the perpendicular forces, stresses you can say, or the parallel stresses. So now what we have to do when you will do that, so what I have to do now here is, this is what, this is sigma x, because now it is parallel to x. These are only the variables. You can write down whatever the subscript is, but the problem is that that is the Mohr circle, and it is invented or developed by the Mohr. So what he took this, what he take it, so I am telling you that one. So this will be tau xy, and here on the top plane, so I am talking about the top plane. So I am going to color it with the color, not with the color pencil, I am doing with the pencil. So this is the shading I am doing it. So now I am going to make it like this. So this one is sigma y because it is parallel to y-axis, so its subscript should be tau yx. Now I am going to take its front face, and I am going to tell you how can you make its front face. So let me tell you one thing. This is all about Mohr circle. So one thing I want to tell you is that sigma represent normal stress, tau represent shear stress. So I am going to write it down here, is that what sigma is equals to normal stress and tau is equals to shear stress. So normal stress is which one? That is normal stress. Normal stress is perpendicular to the plane, and shear stress is what is equals to parallel to the plane. So you have to keep in mind always, it is represented with sigma and it is represented with tau. So now what we have to do in the next step, so I am going to tell you is that I am going to make its front face, this face. I am going to take its front face. So let me do it this face where I am giving pattern. I am talking about this face. So what I am going to do, so let me tell you is that, so this is your front face, and then I will tell you the shear stress and the normal stress phenomena. So this will be sigma x, that is the normal stress, if its direction it is outward. So and this direction is downward, tau xy. So what does it mean by that? Let me tell you. If this is sigma x, so there will be also sigma x, and this should also be outward, sigma x. So what does it mean by that? If it is outward, so it is tensile. So it should be, it is tensile because this is outward. So it should be positive. Okay. And this one is also tensile. So it is also positive. Then if you are having, this is sigma y. Sigma y. So that is outward. So it is also positive. If it is outward, so it will be also outward, sigma y. Always keep in mind. So this one should be positive and this is tensile. I'm just talking about right now normal stresses. So what does it mean by that? For example, I will draw again another front face, and obviously stresses must be acting over there. So in that case, for example, sigma x is outward and this sigma x is also outward. Obviously if it is outward, so it will be outward. And this is sigma y, and if it is inward, so this should also be inward. So this is the rule. So this one decides the direction of this one decides the direction of this one. So this is positive because it is outward and tensile, this is positive, but this should be negative because it is inward and it is compressive. And if you are talking about this, so this is also compressive. So what we have to do next? In the next step, I am going to tell you tau xy. So for tau xy, I must tell you here is what? If its direction is downward, so what we have to do? We have to go with the head to tail rule. So if this is head, so this should be also be head. And if this is head and this is tail, so what does it mean by that? There should be the tail and this is head. If this is head, so this will be head and this will be tail. So head to head, tail to tail, head to head, tail to tail. So this is the way. And in these cases, what is its direction? Its direction is according to clockwise or anti-clockwise. So you have to decide its direction according to it. For example, if it is downward, so its direction will be like this. Now, if it is tau xy, so this will also be tau xy. This is tau xy. If it is tau xy, so this will be tau yx because of this. Direction should be rotation opposite to this clockwise, so it will be anti-clockwise. So what does it mean by that? If it is anti-clockwise, so tau by x is negative over here. And same, if you will check it out, tau by x rotation will again anti-clockwise, so it will also be negative. So this is all about how can you find it out whether shear stress is positive, and how can you find it out if it is negative or positive. How can you find it out? All that what you have to do when you are dealing with normal stresses, so you need to check it out whether it is if it is outward for the normal stress. I'm talking about the sigma. If it is outward, so what does it mean by that? It is tensile, it is positive, and when it is inward, that is compressive and that is negative. And for the shear stresses, the situation is completely different. The picture is completely different. What you have to check it out whether it is clockwise or anti-clockwise. If it is clockwise, shear stress, so that will be positive. If it is anti-clockwise, that will be the negative one. You have to decide shear stresses on the basis of its whether it is clockwise or anti-clockwise. But for the normal stresses, that is sigma, you have to decide it whether it is tensile or whether it is compressive. This is the way you can find it. So let's have a look. I am going to write down as an example. So it will be helpful for you to understand this. So for example, it is sigma x, tau x, and this is sigma y, and tau x. So if it is same, this one is given to us positive, so it should be outward. So there will be sigma x again equals to 30 ampere. I am writing according to this. Now tau xy 45 positive one, so it should be downward because it is clockwise. It should be downward. It is clockwise, so tau xy equals to 45 ampere. Now, one more thing I have to do here is that sigma y. Sigma y is plus minus 25, so it should be inward because it is compressive. And sigma y is equals to minus 25 ampere. And this one sigma y equals to 20 minus 25 ampere. Please don't write plus minus because I can understand it is direction is inward, so it should be compressive and it should be negative. Now for shear stresses, what we have to do, it is head, so there will be head. If it is tail, so this will be tail, so head will be here. You have to decide this direction on which head and tail. You just need this one here. And this one tail will be here. So now this proves tau xy shear stress is 45 ampere. But for tau yx equals to 45 minus 45 ampere. Tau yx equals to minus 45. Now I am going to positive, so it should be outward. Sigma y equals to 35 MPa. So this should be outward. Sigma y is equals to 35 MPa. Now what we have to do, we have to draw shear stress. So it is positive, no, negative. So if it is negative, so it should be upward, because its rotation will be anti-clockwise. So tau xy is equals to minus 20 MPa. Now I can draw it easily. It is tail, so it should be tail. If it is head, so this should be head. This one is also head. Now what we have to do, tau xy equals to minus, so this one tau xy minus 20 MPa. And this is tau yx, so this one tau yx is equals to 20 MPa positive. Tau yx equals to 20 MPa. And the most interesting thing you will see over here, that its direction is like this. So this is anti-clockwise, clock. And if I will see this direction, so this will be the direction again anti. So now you can see these two are anti-clockwise in direction, so these are negative one. If you will see its direction, so its direction will be like this. I'm talking about tau yx, so it will be clockwise. It should be positive. And you can see the magic over here. If it is clockwise, so if I will rotate this shear stress, so it will be also clockwise, and it should be positive. So this is the way to analyze or find it out the shear stress positivity or negativity on the basis of clockwise or anti-clockwise. And for the normal stresses, what we have to do, we have to decide positive or negative on the basis of the stress, whether it is compressive or whether it is tensile. So this is all about the methodology. How can you do all that? So another thing I am going to discuss with you after doing this practice, you can do practice as well at your home. What you can do, you just take simple different values over here and you will try to draw this and send to me on the in the comment box of my channel of this video. So I will guide you whether you are doing the correct job or not. So you can obviously discuss it whenever you find it difficult needed. So this is all about what? This is all about the rules for applying Mohr circle to combined stresses, or it is written over here, whatever I do. So another thing what we have to do is that what is the formula for the radius and what is the formula for the center. So let me discuss what is on for the numerical problems. So for example, this is axis, and what I am going to draw, this is Mohr circle. If it is your Mohr circle, so what does it mean by that? So let me tell you here. This is your plane sigma, normal stress plane, and this is your shear stress plane. So Mohr, what he did this transformation into the circle. And how can he do that? So let me tell you. For example, this is your point C, on which you know the formula sigma x plus sigma y divided by 2. So what he have to draw, we will draw the line over here, and this will be extended. So what is this? This is x-axis, and this will be your y-axis. Then what we have to do, we have to cater out the distances. For example, I'm just going to draw a line over here, and this point is known as G. So this is your perpendicular height, and always keep it in mind, this is 2 theta. For on your normal plane, that is theta, and you have to do twice of theta for the Mohr circle. This is the rule. Now it is D, and this height is tau xy. This height should be tau xy, and this height should be tau yx. Okay, the next thing is what? Next thing is that this distance should be sigma y, and the another distance up till here, this should be sigma x, and up till C distance, what it is, you know the formula, sigma x plus sigma y divided by 2. This is sigma x plus sigma y divided by 2. So we will get the half of it. So this is C point. Now what I am going to tell you, if this is tau xy, so this will be the radius, this is the angle, this point is known as A, and this point is known as, for example, B. So what does it mean by that? So this distance will be what? If this is tau xy, if this is r. So this distance is total sigma x, and this distance is sigma y. So what can I do? Let me update this one. It is this one, because the coordinates of point A will be sigma x comma tau xy, and the coordinates of B should be sigma y comma tau yx. So what we have to do here, we have to sort it out whether it is sigma x, this is total sigma x. So this is r, and this is tau xy. So what we have to write down, sigma x minus sigma y divided by 2. So this is the way you can do it. What you have to do for sigma x minus sigma y divided by 2, because this is sigma x and this is sigma x plus sigma y divided by 2. So what you will do for this, you will write it down, sigma x minus sigma x plus sigma y divided by 2. So you will solve it out. 2 sigma x minus sigma x minus sigma y. So it will come out sigma x minus sigma y divided by 2. So that's why I have taken this. And now you can apply for the radius, that Pythagoras theorem or anything. This is the general state through which you can draw. And one more thing I want to tell you is origin 0, 0. This diagram is already present in the book. You can see it over there. But on this basis, we have to do all the stuff, all the work it out. How can we do that? Let me start the numerical before that. But before going to that, I must tell you one thing more, is that always keep it in mind that in these two normal stresses, there is an angle of 90 degree. And always keep it in mind, if it is theta, so this will become 2 theta on the Mohr circle. And how can we do that? So let's have a look. We are going for the next, for the numerical of the Mohr circle. It is all about the journal methodology of the Mohr circle. But how can we do or perform the numerical? So I am going to tell you in the next video. So hopefully you will understand it. How can you find out the value of C? How can you find out the value of radius? How you have to analyze sigma y, sigma x, tau xy, tau yx. So what you have to do, you have to draw this axis. On the x-axis you have normal stresses, on the y-axis you have shear stresses. What do you have to do? You have to plot 2 points. For example, sigma x comma tau xy is given to you. So what you have to do, you have to plot sigma x comma tau xy point here, and at B point you have to take sigma y comma tau yx. Then you will put this point, so then you have to make this point join. You have to calculate the value of C from that formula, sigma x plus sigma y divided by 2. So you will put your pointer here and calculate the radius from the formula by the Pythagoras theorem, and then you have to draw this circle. And how can you do all these things? So I am going to tell you in the next video. Thank you so much for watching this video. Hopefully you will understand the topic, and it may be clear to all of you. Thank you so much. Before signing it out, I am going to tell you is that don't forget to subscribe my channel, because only 95 subscribers are left. And another thing, must watch it, share, like, subscribe with your friends and family. Thank you so much. Bye bye.